All right, good afternoon. Today, we're going to do an intervention. We're going to lock the doors, all four of those doors back there, and none of us are going to leave until we've all kicked our addiction to relational. So we're going to take, that's right, sit tight. It's going to be hard, but we'll get through it together. So put SSMS under your chair just for an hour. That's all I ask. We have some reserved seats for ADO.net. We'll put ADO.net over there for a little while. And when we're done, we'll all have a new tool in our toolbox to build and run applications in the cloud. And more importantly, when we're done, we'll all stop abusing our relational databases. So we're all data people. We all like data. Let's start with some data. Let's start with some JSON data, because JSON's cool. 1 billion. Last year, we crossed over 1 billion websites on the internet. That number grew 250 million from the previous year. At the same time, the Apple App Store crossed over 85 billion app downloads. So to serve this ferocious appetite, pun intended, that's it, today we have developers working on more than 22 million active projects just on GitHub alone. So it's serving all of these new needs around applications and websites. So you're probably asking, why should I care? What does this data mean? And more specifically, what does this have to do with databases? I think to me, this data says not that the world is changing, but the world has changed. The expectations of users and what they want from applications and the way that we build those applications has changed dramatically. Users want applications across all platforms, all devices, available on the web. They want them personalized. They want them fresh. They want new experiences, week over week, day over day, almost hour by hour, never satisfied. They want faster experiences. They want personalized and social experiences. And as we build these applications, the way that we're developing applications is changing. We're targeting lots of different platforms. We're much more iterative in how we build these applications today. We experiment. We're trying things. We're failing fast. We're deploying new versions continuously. We're using new tools. And we're building applications such that they're expected to scale infinitely. So it only stands to reason that we need the data platform and data processing to evolve to meet the needs of both users and application development. We need a data platform that can handle structured, semi-structured, unstructured data. We need a data platform that snaps to, is internet friendly, uses standard protocols, standard data formats. We need a data platform that can ingest high rates of data and serve data that has infinite lifespan. And we need a data platform that does all of this while being continuously available, highly performant, and completely elastic. So I think for many of us, in particular, some of us in the front row, we might raise our hand and say, we got it. We have a tool for this job. We've had this tool for 20 or more years. Some will debate when that tool was ready or not, but we won't debate that here. But we have a pretty good tool. And at this point, I know many of you, I know I can convince myself that pretty much any problem is a nail. And so we've also taken this tool and we've pushed it into the cloud. So we're done? Are we done? We can all go home. It's Miller time, and call it a day. I think for those of us who are starting to build and develop applications in the cloud, we're seeing how there's an evolution of the data platform and a broader need for more tools. And this meme of the right tool for the job really makes sense as it comes to these modern applications and user experiences that we want to deliver. With the Azure Data Platform, we've really been investing in these tools or in these services across SQL, blob storage, tables, which is a key value store, document storage, and Azure Search. And so the intent is to deliver a set of high-quality tools, but also to help you understand where those tools make sense. Where should you be using one tool versus the other? And as you build applications, where does it make sense to use a multiple set of tools? So today, I'm going to drill down on, there's another one. No? Nothing? All right. Today, I'm going to drill down on document storage. So we're here to talk about Azure DocumentDB. So specifically, I'll talk a little about just document databases in general. If you're not familiar with document databases come from the NoSQL family of databases. And NoSQL databases typically have some familiar characteristics. They're simple, fast, and scalable. These are kind of the key attributes of NoSQL systems that you see across the various types of NoSQL systems. These NoSQL systems and these document databases are non-relational. They don't enforce schema. So if you put data like this into a document database, it will gladly accept it. This is JSON data. You see nice hierarchy. We have arrays. We have a set of properties. And typically, these documents are denormalized data. And you store them in the document database where application patterns require these aggregate views, where I want to get all of the data back as either I'm reading or writing that data. And typically, they conform to a JSON info set, although some document databases deviate from that. This, too, is valid JSON. It's good JSON, good and righteous JSON. But it doesn't really take advantage of the document structure. So if you look at this example, I apologize if it's small for folks in the back. We have an ID field for lookups, and then we have a data field where we've put a bunch of data into that JSON structure. This really doesn't take advantage of the document structure or the info set that is JSON, so it's very difficult for a database to reason over this data. And in data like this, it may make better sense to put in something like a key value store. And so for completeness, and to save myself some time after the presentation when people who don't want to ask the question now will come up and ask later, definitely not these documents. If you want to store Word documents, PDFs, Office documents, this is not the database for you. Blob storage, SharePoint, all good solutions for storing those types of documents. In August, we released Azure DocumentDB as a preview. We went into general availability last month, early April. And as we've been working with customers on DocumentDB, we've seen a set of use cases start to emerge. So I want to share some of those use cases with you. And hopefully this will spur some thoughts on where does this make sense in my business or in my enterprise as I'm looking to build a new set of experiences, and where might I leverage a document database. The first is around catalog data. It turns out that document stores are really good at modeling people, places, and things. So if you think of a profile store is a good example of where we have customers storing document structured data. The other case that we frequently see is in IoT scenarios as a device registry, storing all information for a device or a set of devices that are in the field. Those devices may have different properties based on different models, and those properties may change over time. Preferences and state. The Windows Phone group at Microsoft is using DocumentDB to restore state for phones in DocumentDB. So what this means is when a phone is restored to a state, they pull that data from DocumentDB. Again, they can have a lot of variety in the schema as it changes over time and as they need to store data for different models. Events and logging. This is a case where we're working with a lot of vehicle and equipment manufacturers where they want to log high volumes of data and offer queryability over that data at the same time. And that might be so that they can expose web experiences to their customers that allow them to see insights on that data as it's coming in. But we see that in, as I mentioned, vehicle manufacturers as well as large equipment manufacturers. User data and content. News Republic is using DocumentDB today in their mobile application to store mood information and other user data. And then finally, another really interesting use case is data exchange. If you have a system where you're producing or consuming data and you don't have control over the schema, or maybe you have to interact with another system where that schema is evolving, then this tends to be a good scenario for a document store. In cases where you're interacting with a social network, we see a lot of variability as they change and adapt the schema and social network schema. Or in cases where you're doing B2B exchange and you're exchanging data from a B2B scenario. So this is the highlight reel. This is on one slide how we talk about DocumentDB. DocumentDB is a fully managed service. So no setup, no cluster management. You simply go to the portal, you create a document database, and you're off to the races. It provides flexible schema, so you can do rapid development and rapid iteration over that database. And by default, the service will index all JSON properties in a document. What that then allows you to do is subsequently query over that data through a SQL interface. And I'll show some of that query capability later in the talk today. The other capability that DocumentDB offers is transactions. So multi-document transactions. If I want to update multiple documents at the same time and do that transactionally, DocumentDB supports running application logic in the database. We support that as stored procedures and as triggers. And then finally, DocumentDB is designed to be a scalable database engine. It is a scale-out system. We have systems and experiences at Microsoft today that are running multi-terabyte deployments of DocumentDB. So enough slides. Why don't we walk through what it takes to get configured and started with DocumentDB. So let me switch over to my laptop. I'll also say I'm happy to take clarifying questions throughout the talk. If it's a longer question, then maybe we'll hold it for the end. Yeah?
One quick one. You're only talking about JSON, so XML documents are not part of this.
So the question was, you're only talking about JSON. Are you supporting or talking about XML? The answer is no, we're not talking about XML. The database has made a very deep commitment to JSON. And I'll talk about some of the capabilities that we're able to provide through that deep commitment, but that precludes support for info sets like XML. OK. So I'm going to jump over to the Azure Preview portal. I'm going to change the color. Not that color, that color. Azure DocumentDB management and developer experience is available through the Azure portal today. If you click on the New tab, and if people at the back can't see, let me know, and I'll liberally zoom it, but I'll assume we're OK. But feel free to raise your hand if you can't see, and I'll zoom in for you. Under Data and Storage, you'll see the top two services. The first is our relational database as a service, Azure DB. The second is our non-relational database service, which is Azure DocumentDB. If I click on Azure DocumentDB, I can create a database account. If you've used Azure Storage, it's a similar concept as you think about accounts and creating accounts. And I'll talk about the resource model a little bit later. But to get started, we just provide a name. Right. And we have a standard pricing tier. There's only one pricing tier today for DocumentDB. And then you choose a location where you want to deploy that database account. When you first create a database account, it can take up to 10 minutes. So I'm going to do the cooking show thing. I'm going to go to one that I've already created. This is an empty account. It's in the East US region. So if I want to access the keys, there are a set of master keys, primary and secondary for the database account. And the database account has a well-defined URI. You can see the name you provided is actually used as part of the database account URI. It's prepended. OK. So to create a database, I just go in and I click Create Database. I type IgniteDB. Seems like a good name. And underneath the monitoring data and operations data, you'll see a list of databases. Database accounts can have multiple databases underneath them. Underneath a database, then you create collections. And collections are where you store your JSON data. So I'm going to create a collection called Family Tree. So there's my Family Tree collection. And if I go into Document Explorer, I can add documents to that collection. Right now, that collection is empty. If I click Add Documents, I can then select some existing JSON here. So I have some existing JSON files. They have families represented in those JSON files. We'll go hit Open, and we'll upload those to the collection. So here I have the Wakefield and Anderson family showing up in my collection. If I click on Query Explorer allows me to issue SQL queries over my database collection. So here, all queries are scoped to a collection. So in this case, C is referencing the collection. And if we just run the query, we'll get those two documents that we just inserted. The thing to note here is we have the Wakefield family. Highlight this. The Wakefield family document. And it has a slightly different schema. It includes family name for the children, whereas the Anderson family does not include that property. So we see how DocumentDB is ingested that JSON, it's indexed that JSON is now available to query. So we've gone and we've created our account. Question at the back?
You said it's a NoSQL database.
Yes.
But you still use SQL to query the database.
That's right.
So
Mind blown. So the question was, you told us you were going to talk about, I'll be a little more inflammatory. You said you were going to tell us about a NoSQL database, and now you're trying to sell us SQL. Is this a bait and switch? Is that a fair? So one of the things that we've done is on the query language, I think I talked about NoSQL and the characteristics of NoSQL, the simplicity, the scale, and the performance, and then the other attribute being schema-free. And I think if you look at other NoSQL databases today, if you look at Cassandra or things like that, all are somewhat converging on some flavor of SQL. And I think the reason for that is fairly simple, is that there's such a knowledge base out there today of people who understand a SQL grammar that it makes the database extremely approachable from a query perspective. And that's the same reason that we chose to expose a query interface. Now that said, we will also expose it is not released yet, but we're working on a fluent JavaScript interface. So if you've done things like underscore, so an underscore-like interface to query the database. And that's both from client-side JavaScript as well as server-side JavaScript. Does that answer your question? Okay. So that's a quick getting started with DocumentDB. As you think about applications and how they write data to DocumentDB, there are a few access patterns that will be common. So here I have a case where I have a database. That database has a number of documents within a collection. Those documents vary in schema. They vary in the properties that they have. And in fact, one of the documents is what I would call a bookkeeping document. I might do that for optimization reasons, or I may do that through a trigger, but I'm keeping this other document off to the side. And DocumentDB doesn't prescribe or require that you have the same types of documents within a collection. You can intermingle those types of documents and then do filter querying to find the documents that you're interested in. To interact with those documents within the database, there's a create, read, update, delete, also known as CRUD interface, where you can do CRUD against those documents. DocumentDB also supports a SQL interface. We'll talk a little more about that SQL interface. That SQL interface allows you to query documents. Today, that query interface is read-only. So that means that you can retrieve a set of documents, but it currently does not support things like update and delete as part of DML. The other access pattern is through stored procedures and triggers. You can write application code that you can give to the database and have the database run that application code, and that will be done transactionally. Okay, so now that we've talked a little about just the different access patterns, let me show you just what building an application against DocumentDB looks like. So for those that are adverse to Visual Studio, I'll apologize in advance. I'm going to pull up Visual Studio. For those who are not adverse, we'll be cheering. But this is our only detour into Visual Studio for this afternoon. What I have here is a very, very simple MVC project. This MVC project is a product catalog. I'm using DocumentDB to store a catalog of all my products. And most of the code generated for this MVC project is actually just MVC scaffolding code. So let me just walk you through a few things in this project. The first is the model. In the model, I have a product class. This is just, can everyone see this? It's okay? Do you want me to zoom? Whoops. I got you. There we go. We good? Can you see? You want to, I'm sorry, you want to? Okay, all right. We're like, okay, you come on. Okay, so this is just a simple POCO, plain old C# object. We've annotated some of the properties here to control JSON serialization, but it's a very simple product object. It has a name, it has a description, and it has a property, a Boolean that says is archived or not. In the project, we also have views for the product. Again, these are just, I'll zoom there. Oops. Simple create, edit, and index views for that project, or for the class. Those views are built from the class. Again, very simple MVC scaffolding code. Most of the work in this project is actually done by the controller. There's a product controller. So if we look at the create action, let's just zoom in here. So in the create action, we're calling this helper method, which is called create product async. So I'll do a peek at that function, and we can look and see what that's actually doing. There's a set of helper classes. There's a helper class with a set of helper functions that do things like creating the database if the database doesn't exist, creating the collection if the collection doesn't exist, and writing the document. So if we do a peek to definition on this, we can see that this is just calling create document async. Create document async takes a collection link. So it says, where do you want this data to go? And then we pass it the product object. We don't do anything to it. There's no ORM happening there. We're just giving the database our class object. And we want it to store it, and then we're going to try to retrieve it later. So if I go and run this project, just come down here. As I mentioned, the database, the collections, the data doesn't exist yet. So you think of this as, this is kind of the, if we call code first type development versus, I go to define my schema, I decide how I want my data structured in my database. This is more of a code first pattern. So if we go and we create a product within the catalog, let's call it Windows 10 Great New OS. Okay, we'll create that, and we'll create another product, Xbox Gaming for everyone. Okay. So now we've created these two products in our database. So let's go look at the database itself. Let's go see how that got written to the database. Flip this. Sorry. There we go. Okay. I'm going to go into one of my database accounts. I'm looking for a Product Explorer database that app creates. So I can go into that database. I can then open Query Explorer. And let's just run our select star on that collection. And so here you can see how that data was written to DocumentDB. I have all of the properties that were serialized as JSON written to the database. And then the database has also provided some system properties. All those properties are prefixed with underscore. Those are system properties. The other were mapped directly to that class that we created. So let's say, as things typically do, our requirements change for this product catalog, and we want to change the shape of that class. Someone says, hey, what we really need to track is we need to track that primary hashtag for each product. So let me close this app. We're going to make a change to the class. So I'm not going to touch the database, but I'm going to go into the model, and I'm going to add a new property. So if I make typos as I do this, let me know, and it'll save us all a lot of time. All right. So we're going to call this hashtag. And then we're going to call this hashtag. We're going to save that class definition. So the other thing I need to do now is expose that through the view. So I'm going to update one of these views. Let's update the create view. I'm just going to steal this div. We'll copy that, and we'll swap out description for hashtag. Hashtag. All right. So now our view has that property, our class has that property, but we need to update our controller so that property is passed through on the create. That was the view we just updated. So we go hashtag. We'll save that, and we'll hit F5. So this will load up the index view. Remember, we didn't update the index view. So I actually didn't put that property into the index view, but if I were doing this, I would wire it up on the index view as well, and I would also wire it up on the edit view. But if we go and we create a new product, you see here that hashtag property is there. So let's add a new product, Azure, best cloud ever, and hashtag Azure. We'll create that. And again, That property is not coming back through the view because we haven't wired that up yet. But if we go and we look at the database and we run that same query that we just ran, we see that coming through. That's now serialized to the database. So you see I have some documents that have that hashtag, the one that I just created, and those other documents that don't have that hashtag. So I've just taken an existing MVC app, and I've changed the class definition without touching the database, and I've made that code-first type of change.
Can I ask a quick question?
Yes, of course.
Now, if you want to lay the answer to this because you're covered, that's fine. So
Yeah.
as a SQL guy, what I look at here, I say that's great. One thing I'd like to be able to do is go back to my old records, and for all the records that I didn't have that hashtag entry for, put a value.
Yeah. So,
Is there a
yeah. So the question was, hey, that's great, but for all of these values that don't have that property, I want to be able to go back and actually add that property. So there are a few facilities for that. One is you can execute a stored procedure that goes and walks the database and introduces that. You can add a trigger that the next time that record is touched, that hashtag is added, or a trigger that when a new record is added, that it goes and looks for that hashtag and adds that hashtag. So there are a few different ways to do this. Or you of course could write a program to go backfill that data. Yeah, question?
Even you need to add that column back, would
It-
it mean that like the absence of that column is just null then?
So the question was, do you really need to add, I'm not going to use, the word was column, but I'm not going to use that word. That's your habit. I'm just kidding. So the question was, do we really need to add that, we'll call it property, because won't it be null if it just comes back? It really depends on how your app behaves on deserialization, if it's expecting it or not, and if it's doing null checking or not. And so in some cases, you may want to backfill the data. In other cases, you just want to handle it on your app layer and have it be resilient to that. It depends, again, on the app pattern. Okay. So that's just a quick walkthrough as you think about building an app with DocumentDB, modifying an app and evolving the app and iterating on that app. So before we get deeper into DocumentDB, I think it's helpful for all of you to understand, and for us to understand the resource model. I'll walk you through the resource model, but this will give you a sense of what things or entities exist in the system, where does it make sense for me to put my data, and how should I interact with the system. So at the very top level, the thing that we've walked through is a database account. A database account has a unique DNS name. As we saw when you created that, you provide that to the system. It's also an access boundary, so a primary and a secondary key are available and can access the account. We also have read-only keys, so if you have read-only patterns that you want to access your database account, then you can hand out the read-only key to do that. Billing also rolls up to the account. An Azure subscription has a database account, and then billing rolls up to each account. And then each account is assigned a default data consistency. I'm not going to talk a lot about data consistency today, but DocumentDB offers 4 different consistency levels. We offer strong consistency, we offer eventual consistency, and then we also offer session consistency and bounded staleness. There's a whole bunch of documentation on this on the website, but really this affects your read performance and also your write performance as you choose your data consistency. But we give you some dials in which you can choose at the account level, and then at an API level if you want to override that. If there are cases where you just want a fast read and you don't care if you get stale data, you can opt into looser consistency levels. Okay, underneath an account, you create databases. You saw me walk through the database creation there. The database provides an authorization namespace. So underneath a database, you can create a user. And again, this is an authorization entity, so you could do it for roles. It is not an authentication mechanism. But you create a user, and then you can assign resource level permissions to that user, all the way down to the document level. You could say these documents are available for read or write for a particular user. Each database doesn't have a practical limit in terms of scale size. You scale out by adding collections. So collections are the means at which you actually scale out databases. These databases are designed to scale out. The way to think about collections, think of them as data partitions. And you can create more data partitions. Today, we limit through the portal collection count for a database or a database account to 100. But there's actually a link in the portal that says increase my quota limits, and if you want more, you just click that and you submit a request, and we'll crank that up for your account. Each collection also is the namespace for execution of stored procedures and triggers. So it is the transactional boundary. So if you're executing code, this JavaScript code that you provide the database to run, that is all executed within the boundary of a collection. Queries are also scoped to a collection. So if you want to do queries across collections, then that has to be handled at the application layer. I'll talk a little about, we introduced some sharding framework last week at Build. I'll talk a little about that. That kind of eases as you think about different sharding and partitioning patterns, but we'll get there. Each collection is also assigned a performance level. So we reserve performance at the collection level. And as you create collections, you can specify the performance level as S1, S2, or S3. You can also change that over time. And then documents, this is application-defined JSON. So this is whatever you want it to be, whatever you need it to be, whatever your app says it should be. And you can put this into a collection. Again, no enforced schema. By default, we index all of the properties within that document. I'll say I'm not going to cover indexing policy in depth, but we also offer an indexing policy. So if you say, hey, listen, I'm going to give you all of this JSON, and there are maybe 5 properties that I'm ever going to query over, you can specify that, and so you can tune the indexing policy to meet the needs of your application. Question?
What's the limit on the number of documents or space in a collection?
So the space, if we go back, the size of a collection today is a maximum of 10 gigs. So there's no maximum number of documents, but if you fill that up, it's time to move on to a next collection. And again, we provide I'll talk a little about our partition resolver that helps with that scaling.
The database is type agnostic, right?
Yes.
Only strings.
So the question was, the database is type agnostic. So DocDB supports all the native types of JSON, which means all the good and the bad of the simplicity of JSON, but the lack of things like the obvious date time not being a supported type. So you get ints, you get arrays, you get strings, you get booleans, but then you're kind of done. And typically, different serializers, JSON serializers will handle different types differently. So with DocumentDB, we use the Newtonsoft JSON serializer, and you can decide how you want things serialized as they go in and out of the database. That said, all resources are accessible over REST over HTTP. So if you want to access through REST calls over HTTP, you can do that. You can decide not to use any of our SDKs. You can use directly REST to interact with the database and all of these resources. So all of these resources have a well-defined logical URI that's durable, so it's not going to change on you, and you can use that to interact with the system. All of the resources are partitioned for scale-out and replicated for high availability. We offer multiple connectivity modes. Today, TCP connectivity is only available in the .NET client, but we'll be adding it to other SDKs in the future. So in terms of question?
In terms of the REST endpoint, all the verbs get put update, all that supported?
So the question was, do you support all of the HTTP verbs? You didn't mention the one that we actually don't support. Yes. We do not support patch today. That is the one verb that we don't support. That's something that we are working on. So we're working on patch support. But all the other HTTP verbs we support. SDKs are available. Yeah, question.
Do you have any plan for Swagger support?
I'm sorry, what?
Swagger support?
Swagger support?
Swagger? The Web API, Swagger?
I don't, we can talk later, but I'm not familiar. So, no, I apologize. I should know. Okay, so SDKs, we have a .NET SDK, Java SDK, Node SDK, Python SDK, and a JavaScript SDK. As you've seen, there's a lot of the management and development experience available through the portal today. We also offer what's called the DocumentDB Studio. We have a set of tools that we've open sourced. These tools can be run outside the portal. They're Windows applications. DocumentDB Studio, I'll show in a little bit in one of my demos, allows you to interact with some of the data inside of DocumentDB. We also offer a data migration tool. So that data migration tool allows you to take some of the data that you might have. You might have data in relational systems. You might have data in CSV form and JSON form, and allows you to bring that into DocumentDB. So let me show you a demo of getting some of your data into DocumentDB. So I'm going to pull up the data migration tool, which is not there. Okay. So this is the data migration tool. If you want to start a migration or an import of data, you click on Next. This is available through Microsoft Download site. The source is also posted to GitHub. Today, we actually released a new version of this tool. I'll show you some of the new options that are available. Can everyone see that, or should I? Whoops. There we go. Okay. So I can import data from JSON files. So if I have JSON files just laying around that I want to import that data from, I can do that. If I have a MongoDB instance, I can connect to that MongoDB instance, and I can pull data into DocumentDB. We also support Mongo export files. So if you have a Mongo export file and you want to take that data and bring it into DocumentDB, you can do that. We also support bringing data in from SQL Server or Azure DB. So if you have data in those systems, and I'll show you an example of bringing some of that data into DocumentDB. CSV files are also supported. One of the new options that we've added is Azure Tables. So if you have an Azure table that has some data and you want to bring that into DocumentDB, then the migration tool can be used for that. And we support taking data from one document database account and moving it to another document database account. With the JSON options and the file options, we've also added this button that if you've used the migration tool previously, you wouldn't have seen this button. This says Add URI. So this says if you have data in blob storage, in JSON form, in CSV form, or in Mongo export form, you can just point us to that data, and we'll go fetch that data. It's also quite handy if you have data, if you want to play with data like from data.gov, has some really interesting data sets. You can just provide us a URL to data.gov, and we'll pull in that data into a DocumentDB collection. So today, yeah, question?
So if I'm going to have MongoDB, why would I go into DocumentDB?
So the question was, you're not gonna give me more softballs before you give me that question? Or no? And now for something, no. So the question was, if I'm using MongoDB, why would I use DocumentDB? Is that the question? Okay. So, and we've worked with a number of customers that either were looking at Mongo or are looking at Mongo. And of course, I'll give the pitch. If you want to run Mongo on Azure, Azure's a great place to run MongoDB. And you should, I'm sure you can work with one of the partners, either Mongo specifically, Mongo Lab, Mongo HQ, and some of these partners to help you run that. I think some of the things I talked about up front, like no cluster setup, no cluster management. We've talked to a lot of people who have run Mongo clusters, and more often than not, they want to get it out of the business of running those clusters. So I think the ease of use and ease of management associated with a fully managed platform as a service is particularly helpful for those who don't want to do that. And I think there are other set of features that if you're looking for in DocumentDB, that we provide things like the multi-document transactions. That said, Azure is a platform of choice. And so if you've made a significant investment in Mongo or you think it's the right database for your app, then you should use it. And we're dedicated and devoted to making DocumentDB a great document store. But that certainly doesn't preclude the use of other document stores. So there's my answer. OK, so let's pull some data in from a SQL Server. Because what is a database talk without some AdventureWorks data? So I'm going to take data that's in an AdventureWorks database. And our good friends over in Azure DB, you can create an AdventureWorks database pre-populated as an Azure database. So I actually have one of these running over in East US. So I'm going to add the connection string. And that's going to connect to my SQL database. That seems to be working. And then I'm going to grab a query. So with the migration tool, I can actually pass a query in, and then it'll use that to pull the data out and insert it into DocumentDB. There's a couple interesting things to call out here. So what I'm doing is I'm going to the AdventureWorks database. This is a relational database, and it has a product catalog that's has normalized data. It's split across multiple tables, and I'm doing multiple joins to pull all of that data together to provide an aggregate view of each product. The other thing that I'm doing through this query is I'm using this dot notation. So you see model.id. What I can do is I can actually tell the migration tool my nesting separator. So this helps me get hierarchy in my document. So as I'm denormalizing that data as it's coming into DocumentDB, I can provide a nesting separator. So here we're using dot as the nesting separator. OK, and now I will give my connection string to my DocumentDB account. Let's put that in there. And we'll add this to the products collection. And I'll tell the tool to use ID as the field. So we'll run that. And there's about 300 records, so it'll grab it from the AdventureWorks database, and then it'll post all those records up to a new collection up in DocumentDB, in the DocumentDB account. OK, so let's go take a look at what that data looks like. Go home. We'll open up this database account. This database account, we created a new database called short form for AdventureWorks. And if I just open up Query Explorer and I run that select star again, here I can see the product data. Let's zoom a bit. And here you can see how we've created hierarchy in this document. Each document has a category. It also has a model. And it has a set of properties that are associated with that document. And so then we've also done type mapping. So the migration tool will do type mapping into DocumentDB. You can tell it which types to map to. If you don't tell it, it will, in some cases, make its best guess. So you may find cases where you have to be explicit about pushing something into an int. OK. So that's getting data into DocumentDB. As I mentioned, for the migration tool, we have a set of new features that are available. You can grab from Azure Tables. You can also grab from Internet accessible URIs. So where you have data, we can bring that data into DocumentDB. Let's talk about query. So as I mentioned, DocumentDB will index all properties of a JSON document. This is the default behavior, but you can control the indexing policy of the database at the collection level. The query language allows you also to do expression evaluation. So if you have arithmetic functions that you want to run as part of query, or if you want to specify user-defined functions, that those can be invoked as part of query execution. So you can say, hey, I have some custom logic that I want to do, and I want to execute during query processing. And so DocumentDB will invoke that custom logic as part of the query processing. DocumentDB is write optimized. So what that means is on ingestion of all document data, that data is immediately available for query. So there isn't a lag in when the data will show up when you start issuing queries. It's immediately available through the SQL interface. The query language also supports predicates, projections, and hierarchy. I'll show a little about hierarchy. It also has some extensions to support arrays, because arrays are an interesting animal in terms of JSON, so we had to map that to a SQL grammar. I'll show a little about that. In C#, you get a link interface if you want to use a link interface through C#. And if you're using the SQL interfaces, we support parameterized SQL. So let me show you some of the queries against DocumentDB. Any questions before I start on query? The question was, can you join against, take DocumentDB and join against existing or external data? Is that right? Like in, for instance, in SQL. Is that, sorry?
So you have one SQL server with your pre-existing DocumentDB. Can you write a query to join them?
Yeah. So the question was, can you write a query to join across a SQL instance and DocumentDB? The short answer to that is no. Although there are certainly things that we're looking at with Polybase where we may look to support that in the future. So we'd love to hear feedback on where those scenarios are interesting to you. Okay. Yeah, question.
So when you are importing data from relational databases, can you do relationships as nested types?
The question was, as you're importing data from relational databases, can you do relations as nested types? Is that right? So you want to nest it into the document. Yeah, so I didn't show you the SQL query. That is actually what I was doing. I was taking those relations, and then I was nesting them under the product parent. So I was denormalizing that data.
Is there support for referential integrity of any sort?
Question was, is there support for referential integrity of any sort? No. But I'd love to hear more about the scenarios where you want to do referential integrity. We can talk later. There's some things that we're looking at that might help those scenarios. Okay, so let me open up the Query Explorer. I'm going to open up the products database. I actually have an AdventureWorks database that's pre-populated. This products collection also includes product categories. So I'm just going to walk through a few of the queries that show you some of the SQL grammar and different things that you can do when you're querying over data.
Real quick, pull down what you have under collections, since we all know that database here, so you can see what's parallel with it.
Sure.
Yeah, so, okay.
We have, this was one that so the one that I just created was this one. And it's just that collection, AdWorks with products. I have this other database, which is the same data, the AdWorks data. The only difference is that I did another import where I took the product categories from the AdventureWorks database and I pulled them in. And you'll see why I'm doing that. I just want to show some of the array iteration support in the SQL grammar, and none of the products that I was bringing in had arrays. So that's the, oops. Yeah, don't look at that. It's my key. Okay. So let's run through some SQL queries. So we've already done one where we grabbed all the products from the database. Let's do another one where this is a simple filter query. We're just looking for a product with a specific product number. So we can run that, and it responds as I think you would expect. It brings back the JSON document for that particular product. But if I didn't want all of the properties for that, let's say my app expected different properties or only cared about certain properties, I can do projections in the query. So if I go and I update this, so the thing I want to show is this. So in the SQL grammar, see, I'm referencing a property. I'm referencing p.category.name. So we use dot notation for hierarchy. So as you want to navigate down the hierarchy of the document, you reference those properties using dot notation. So we can then run this query. And then we just get the properties that we asked for. So let me show another query. If I'm looking for multiple, let's say I'm looking for multiple documents, I want a set of product IDs. How many people have used DocumentDB today? Just a few people. So if you've used DocumentDB today, then you may have even called us and said, hey, you need to increase our OR clause count because we do have limits on different things, and you can you can submit a support ticket and we'll adjust those for you. One common one is for OR clauses so that you can do in. In all of the regions, we now support in. So this actually wasn't there until late last week. So all of your existing document accounts, if you have them, you can issue these inquiries today. We have a set of other built-in functions that we'll also talk about on Thursday. We'll do a blog post and release some documentation that talks about that. But here I can do an in clause. We also now support between. So if you want to do a query with a between operator.
Sorry, I'm pestering with these questions, but I'm just curious, MongoDB or other JSON-based document databases, do they use a similar query syntax? Is there a standard, like there's a, sort of a SQL standard, or is this sort of a Microsoft invention?
So the question was, do other document stores support SQL-like query interfaces? Are you guys at Microsoft cooking this stuff up on your own? So the short answer is, depending on the document store, there tends to be different query interfaces. We'll take Mongo. Mongo doesn't really have a SQL interface where you can issue queries over SQL. There are other document stores that have SQL-like interfaces, but unfortunately there really hasn't been a standard yet that's emerged. So we're definitely very interested in working towards standardization. And so across a number of fronts where you're querying across JSON. And so there's a lot of interesting possibilities there. Okay, let me show you how to invoke a user-defined function. So here, the weight within the product document is in grams. Let me just zoom a little bit. So here I'm invoking UDF. I've written a user-defined function stored in the database that's grams to pounds. I just pass in my weight, the weight from the product document, which is in grams, and then it'll do a conversion to pounds. And then that's executed as part of query processing. So we ran that. Yes, sorry, question.
Are all of these supported through the REST API as well?
Yes.
All of these are.
The question was, are all of these supported through the REST API? Yes, all of these, all of the SQL grammar is supported through the REST API.
In the backend calling the REST API?
Yeah, that's right. Yes. Okay, so let me show you, because of this, the simplicity of this UDF essentially is just doing math. And we do have built-in system functions for arithmetic operators. So here's an example where I'm doing a variety of things. One is I'm just getting the weight back in grams. The other is I'm invoking this UDF that says convert the weight from grams to pounds. And the other is I'm using these system functions like round, where I'm taking the weight, I'm multiplying it by a factor to get it the pound version, and then I'm just rounding it down to the next int. So here you see, we'll run that query. And there I have the results there from invoking those. The question was, when you filter documents, is there a difference between documents with properties that do exist and proper? Yes, there is a difference. Yes, because you can do an is null query. Yes, question.
Math is easy. In JSON, dates are hard.
Yes. The question is, math's not easy for everyone. The question was, math is easy for databases, but dates are hard in JSON. How do you handle dates? So we don't do explicit date support. What we do is, and we have some samples written up on this, is we encourage people to use epoch dates. So that then you can do range queries over those dates, and it works a lot better. I'm sorry, it was. Yes, between would also work on that. So we have some documentation that walks you through how to handle dates, but because of we're adhering to the JSON spec, we don't jam dates, and there's a lot of different takes on how serialization and deserialization should happen in dates into JSON. Okay. So let me just, yes, sorry, question.
So you did say that the data store is schemaless, which means it can have any different types of properties between two documents within the document. When you do a select statement like this, and you're querying for a particular property,
Yeah.
which is not there in another document, what happens to that document? It has all the things except one of those properties.
It won't get.
Does that document show up or it doesn't?
Oh, I see. When you do a projection and it matches the filter criteria, but it's not the properties is missing. I believe that I have to run this query again, but yeah. Yeah, that's right. So although actually I'm not doing a filter query on that. Yeah. Yeah. So, but I'm also doing a select star. I'm not like specifying projections. But I think that the document comes back. I'd have to run this again, but last time I ran it, the document came back without that property. Okay. So let me I want to be conscious of time here. So here's an example of a document with arrays. And one of the interesting aspects of DocumentDB is you can do array iteration. So here, if I run this query, what array iteration allows me to do is I iterate over all the elements in that array, and I can flatten the results. So it's effectively a self-join while flattening the result set of those documents. I know that one's a little bit tougher to digest. And then finally, just from the query perspective, the SQL grammar also supports JSON construction. So you can manipulate JSON, you can shape JSON, you can materialize your own JSON as you do query evaluation. So here's a case where I might have an app or a system that's expecting a specific format or a specific set of properties. So here I'm being very explicit in saying I want this property name to be category, subcategory, and then I'm concatenating category ID and subcategory to create a new property in the resulting document. And so yes. Yeah, so we're trying to, so I think largely as we look at the projection and the construction there, we support JSON in those projections, but I don't think we'll go much further than that. The question was, you're starting to look like a lot like LINQ. Okay. So we just did query over JSON. We talked about new in operator. There are also some new system functions. Between is also something that's supported now. I'll talk a little about short-term and near-term roadmap towards the end, and I can talk a little about things that we have queued up that we're planning. In terms of integrated JavaScript, I've talked about stored procedures and triggers. I think the best way to show this feature is to actually just run a demo for you. So what I'm going to do is I'm going to launch the other tool I mentioned, which is the DocumentDB Studio. DocumentDB Studio allows me to browse the resources and interact with the resources within DocumentDB. So here I have a collection called Sprock Demo, or Stored Procedure Demo. And in it is a function, we'll zoom in, that takes a product ID, it takes a user ID, it takes a rating, and it takes a comment. So what I'm trying to achieve here with this stored procedure is I want to allow users to rate products, the products that are in my product catalog. And I want each rating document to be a document unto itself because I don't want the product document to grow unbounded. As more ratings come in, then I'm going to lose control over that particular document. So I don't want to embed all of these ratings documents into my product document. But at the same time, I want my product document to have a roll-up of the ratings. So what this stored procedure does is it actually creates a ratings document and then rolls up the rating into the product. So it'll do an evaluation of what the current rating is, and then it will add that to the product document based on the new rating. So let me just invoke this. Okay. So if I pass in these parameters, you see that I have two documents there. So we're going to pass in the product ID, which is here, the user ID, a rating, and a comment. I'm going to execute that, and the response from that stored procedure is an update to the product document. So here you can see there's now a rating property. The rating property has the score, the overall score, and the weight. So how many votes have been done, so that as a new rating comes in, I can weight the rating relative to how many votes there have been, and I can update the product document. There's also a review document now. So you can see here that was written. What will happen is if you pass in the stored procedure is written such that if you pass in a product that doesn't exist, the stored procedure will throw. It'll throw an exception, and that will implicitly roll back the transaction. So the review document will not be written, and the product document will not be updated. So that's just an example of how to use or how you can use stored procedures in DocumentDB. Yes, question.
Are there any plans to have a debugging experience?
The question was, are there any plans to have a debugging experience? The answer is yes. We know there are a few things that we want to invest in. One is the management experience for stored procedures and triggers, and then the other is a debugging experience. Okay, so one of the last topics I want to hit is performance levels. If you've used DocumentDB during the preview, performance levels were not something that we offered. And with the GA release, we introduced performance levels for each collection. Each collection has an associated performance level. Think of them as good, better, best, S1, S2, and S3. And so as your application needs change, let's say that all of a sudden your S1 collection starts getting a load that it can't handle, the database service will return to you 429, which says request rate too large. You're being throttled. You can then adjust the performance levels of that particular collection to meet the needs of your application, and then everything will be honky-dory. So throughout the collection's life cycle, you can change performance levels to S1, S2, and S3. So I have a quick, I think I can squeeze it in, last demo on performance levels. So I'm going to pull up a VM that I have in Azure. This VM has a client application that spawns up a bunch of DocumentDB writers. These writers are just writing documents into a collection. That collection is an S1 collection. So let's specify 10 clients to concurrently write to DocumentDB. These clients are happily writing to the database. Green is good. They're writing to DB's Ignite Perf collections, items, docs. So that's happy. Those 10 clients are just fine. But if we dial up the number of clients, so let's say, let's do 100 concurrent clients, we'll see a less happy result. So some of those inserts are happening. Others are getting throttled with request rate too large. To address this, I can go into the portal. Actually, I hit the wrong. Let's go here. If I go into the portal, I click on Ignite Perf. And here's my collection. I can adjust the performance level of that collection. So let's splurge and say S3. We'll move that collection to an S3. So as performance levels are set, the system will then go and allocate resources, processing resources to that collection and dedicate those resources to that collection. In practice, this happens typically in 2 to 3 minutes. You'll have the performance level reflected in your collection. It can be as long as 5 minutes. And so what we'll see is if we let that client continue to run, that eventually all of those requests will start to go through because the performance level's been adjusted. The other option that you have is on creation of collection. You can specify a performance level. That's supported through the portal. It's also supported through the APIs. Yes, question?
So can I see the effect of the throttling here in the monitoring experience?
Yeah, so the question is, can I see the effect of the throttling here in the monitoring experience? So if we go here, this is my database, and if I edit, you're taking me off script, but let's do it. And we select throttled requests. So there is let's see here. Actually, let's do it it's at the database level. Let's do it at this. Let's do it here. So I think that database did not exist. There we go. I just created that database, so the throttling activity hasn't shown up yet. There is a lag between monitoring as it comes into the portal. But there you can see the total requests and the throttled requests as part of the overall request patterns. Question is there any way to auto-scale this? Today we don't have integration with auto-scale, but it's definitely something that we're looking at. Okay, so there you go. We're turning green, and we're happy. So that's fine. That's taken effect. So that's performance levels. Again, you can select those performance levels on creation or during the life cycle of those collections. Performance levels are measured in request units. Don't confuse these with requests per second. Request units are a measure of work. So depending on the request type that you're issuing, it will have an associated request unit cost. And this is returned in the header. It's also exposed through all of the API responses, and it's exposed in the portal. So you can look at each request and see what the request cost is associated with it. On scaling for collections, as I mentioned, databases scale out through collections. Last week we introduced SDK support for a partition resolver. Partition resolver allows you to specify a sharding or partitioning scheme. You can specify range-based or hash-based partitioning. Then that allows you to make requests at the database level. You can also implement your own sharding scheme or partition resolver. So if you have a custom scheme that you want to implement, you can plug it into the SDK and do that. But this will allow you to balance your data across multiple collections or multiple database partitions. As you use DocumentDB more, we offer integration with Azure Search. Liam is here. I think Liam has a session tomorrow on Azure Search. There's a no-code experience for integrating with Azure Search. You can write an indexer, which will pull that data, and then you can build full-text search web experiences on top of Azure Search and DocumentDB. We also support integration with HD Insight. Andy's in the back of the room as well. He's from the DocumentDB team. Andy's doing a session tomorrow on Hadoop or HDI and DocumentDB. This is a great way to do analytics over data within DocumentDB, as well as if you want to use DocumentDB as an output source for jobs that you're running in HD Insight. So with that, here are a few pointers on getting started. I didn't talk about the Query Playground, but the Query Playground allows you, without signing up for Azure, without having an account, you can run queries within DocumentDB. We give you a sample set of JSON, and then we give you some sample queries. It's a good way to get familiar with the query interface, so there's a short link there. But if you go to documentdb.com, there's a link to the Query Playground on the service page. Getting started with building an app, there's another link there, so that's a good getting started. It'll walk you through some of the MVC scenarios that we walked through today, and then importing some data is another way, a good way to get started with DocumentDB. I will hit quickly before we wrap up near-term roadmap. By near-term, I'll say within the next 2 months. The top things that we're working on within the next 2 months is, the first is ID-based referencing and routing. So if you're using DocumentDB today, how many people know about a thing called a self-link? Have discovered the self-link. So we will be removing the need to use self-links within the next couple months, and you can do ID-based routing. So this is the ID that you provide. We'll honor that, and we'll allow you to address and route based on that ID. Today you use self-links. The other feature that we're working on in the near term is order by. So order by on both numerics and strings. So these are things that are coming soon to an Azure data center near you. Okay, so I think that's it. I want to say thank you. Again, tomorrow there's a session for DocumentDB and HDI. I encourage you to check that out. It should be fun. And there's a hands-on lab if you want to get your hands dirty with DocumentDB. So I'll take questions. I know we're probably over time, way over time. But I'll take a few questions.
I guess the question is, will this ever be able to be routed as a private virtual network in Azure?
I'm sorry.
Will you be able to route this on a private virtual
Yeah, so the question was, today this is exposed through an open DNS. It's effectively internet accessible. Will it ever be routable? VPN or VPN plus firewall? What is the behavior, and or both?
Yeah, just not open.
Okay, so we are absolutely looking at how to lock it down for both VPN scenarios as well as firewall scenarios where you can restrict access to the database account. The Azure storage team started to do some of this work recently as well, so I'd love to get feedback on whether you like that model or whether you're expecting another model for access restriction.
We're only exposing like a limited set of services, and we're not
Yeah.
using any services that have like an open DNS
Yeah.
unless they are meant to be public.
Yeah.
So that's kind of one of the, we're looking at an experiment like that. We want to lock down any kind of, we don't want outside access.
Yeah. Totally get it, and so it's definitely something we will do that at some point. I just don't have a date on that at the moment.
Is this available on-premise?
The question was, is this available on premise? Short answer, no. Scenarios, is this development scenarios or full deployment scenarios? Both? If you were to prioritize one versus the other? Dev, a vote for dev. Both. Don't make me choose.
We need to do the development, flush it to work out the kinks and all that.
Yeah.
But it would be a full-scale production.
All right, so you want to emulate a full-scale deployment.
Government restrictions on data being in the cloud.
Yep.
And legal entities within the organization say, you can't go to
Yep.
Azure, I'm sorry. But
Got it.
we want to make use of this product because there's so much potential with semi-structured
Yeah.
stuff.
Yeah.
So how could Microsoft help us get to that point?
Yeah, so we don't have immediate plans, certainly in the space of bringing the full product on premise. So, I'll tell you candidly, I wouldn't expect that within the next year. But it is something we're evaluating as, certainly as we look at, offering hybrid solutions and our value prop of Azure as a hybrid cloud, and how do we enable that as something we're looking at, absolutely. Yeah.
Support for aggregation queries or MapReduce.
So the question was, is there support for aggregation queries or MapReduce? So on the MapReduce side, we do have some patterns that I think Andy will walk through tomorrow where you can do if you're doing analysis type jobs. But if you have app aggregation or aggregate type queries, that's currently not supported. We have different patterns that we talk to people about. Like you saw in one of those examples where we had these aggregate documents that are being maintained. Longer term, we do intend to support aggregates and aggregate views. It's just something that's not there yet.
Can you use DocumentDB as a data source for Power Query in Excel?
So can you use DocumentDB as a data source for Power Query and in Excel? So you want native Excel, like ODBC connectivity? Is that?
That's the Power BI.
Yeah. And so stay tuned. We're definitely working on that.
This one is to S3 level. What does it do in the back end? Why do we want to even do that? Was it cost involved?
Yeah, so the question is S1, S2, and S3, what does that do in the back end? So every physical node has a set of resources that it can offer, CPU, I/O, memory. We pre-allocate budget for that. So, and we also do very strong resource governance so that there are no noisy neighbor effects for a multi-tenant system. And that pre-allocation tells us where we can put particular tenants and when. And so if you tell us, hey, I need this level of performance, then we won't pack those nodes as densely because you're consuming more of the resources in those nodes. And so that's what happens in the back end, is that... Oh, yeah, so the pricing is different. So we do hourly pricing, and as you change the performance level, as you increase the performance level, the price will go up.
But
Yeah. Yeah.
Since you can just do it for that short period of time.
That's right. Question.
Can you create queries with joins across collections?
The question was, can you create queries with joins across collections? No, not today. Okay, now I'm getting the hook. I'll stick around and be outside if people want to chat more.